This is question 6 from the PPE in March 2020, and it's asking us to have a look at how to use the trapezium rule to estimate the area labelled with R in this case. The equation of the curve, y equals 2 to the power of x squared minus x. It's a little bit tricky one, but it should be fairly straightforward. So let's have a look at the start of the question. So I think the first thing that you should do when you're working out the trapezium rule is you should work out your value of h. And this is fairly straightforward. It is, if you're dividing this into 4 strips, which is what the question specifies, then it's the width of each strip here. So how are we going to work that out? Well, look, if we find the gap here between the lower bound and the upper, I say lower bound and upper bound, the lower limit and the upper limit, divide it into 4, then we are going to get our value of h. So you can see that's what I've done here, and your value of h comes out to be 1/2. Once you've found your value of h, it's time to look at the trapezium rule, and I've written it here how it's written in your formula books, just so it's a bit familiar to you. And the idea is we're going to do half h, and then we're going to times that by a load of the y coordinates all sort of added together. And in order to do that, I've started to write out a table. So let me just scroll down a little bit. There we go. So what I've recorded in my table is the x coordinate that I'm working on, the y coordinate that goes with it, and then the weighting from this formula here. So you can notice, look, that the first and the last y coordinates are multiplied by 1, essentially 1 y0 and 1 yn, but then all the middle ones are multiplied by 2. So if I scroll down a little bit on my chart, look, you can see the next thing is going to be multiplied by 2 to match the trapezium rule. So we're just going to start off with this first row. Remember, what we are doing here is we are finding the y coordinate that goes with the first x coordinate. Okay, so to find that y coordinate, I need to substitute minus 0.5 into my formula, my equation. So here's my minus 0.5, and here's me substituting it into the formula I've been given. And the answer you get when you type that in your calculator, 1.6892. And because in the trapezium rule, you only need one lot of y0, I'm going to times that by 1. Okay, and that number there, we're going to use a little bit later when we're adding it all together. The next row of my table has got the next x coordinate, which is 0, and the y coordinate that goes along with it. You can see I'm substituting my numbers in there. And 2 to the power of 0 is 1, take away 0 is 1, and then when I double it, it's 2. Remember, I'm doubling it because this 2 in the trapezium rule tells me I need to double all of the y coordinates except the last ones and the first ones. So the next y coordinate can be worked out with 0.5. So 2 to the power of 0.5 squared minus 0.5, and you should get 0.6892. And then when you double that, 1.3784. The next row is a bit easier again, so it's 2 to the power of 1 squared, so that's 2, take away 1 is 1, and then remember we double it. And the final y coordinate you need to work out, which is equivalent to this yn here, right? We would call it y4, so y0, y1, y2, y3, y4. The value of y4 in this case, putting 1.5 into the formula, you should get 3.2568. Once you've worked out all of your y coordinates and sorted out the weighting of them, notice that it's the first and the last which are multiplied by 1, and everything in the middle is multiplied by 2. You can then proceed to put this all together. So remember, the trapezium rule says that we're going to do half h, and then we're going to multiply it by all of these things. Now these things in the curly brackets are these numbers here. So I need to get the total of those, which turns out to be 10.3244, and then times that number. Remember, that's the total of things in that curly bracket there. So everything in the curly bracket adds up to 10.3244, times it by a half h. H, as we discovered earlier, is a half. So this is a half times a half, in other words, a quarter. And that gives you the answer 2.5811. Like that. And if I can find the question, it's a 2 decimal places, so I'm going to give my answer as 2.58. Oh, you can't see what I've written there. Let me just go through that again. All right, so I was just doing a half h times that number. That's a quarter of that number, and it ends up being 2.58. Okay, the second part of the question says, explain with the aid of a sketch of figure 3. So figure 3 was this one. Explain with the aid of a sketch of that whether we have got an underestimate or an overestimate for the true value of r. So just really quickly, let's have some sort of approximation of that curve. It's not very good, but okay. And this was r. We had to explain whether we've got an underestimate or an overestimate. Well, let's pop in those trapeziums. Now I'm going to draw dotted lines like this. And hopefully you can see that the top of these trapeziums, which is what we've worked out, remember we've done the trapezium rule, so we've worked out the area of these under these dotted lines, and the real area we want curves underneath that. So what we need to say is we've worked out an overestimate because the top of the trapeziums are above the curved line, something along those lines. Okay, part C. Part C was quite tricky. Let's have a look at what it says. It says, using your answer to part A, which was a crucial part of the question, and showing your working, estimate the value of the integral of, and you can see there, 2 to the power of x squared plus 1 plus 2x. So, how are we going to do that? Well, let's just write out on this piece of paper what we're trying to do here. So, minus 0.5 to 1.5, 2 to the power of x squared plus 1 plus 2x dx. So the first thing to notice is that this is similar to what we found in part A. Let's just write down what we found in part A quickly. So we found an estimate for that. Okay, we found an estimate for that in part A. So it's clearly related in some way. Let's see if we can work on this to make it look a bit more like that. So what I'm going to do is I'm going to think, okay, that plus 1, I can sort of use my laws of indices to rewrite that as 2 to the power of x squared times by 2 to the power of 1. Remember, the laws of indices say if you're multiplying, then you add the powers. Well, here we've got powers which have been added, so we're going to sort of work that backwards, separate them. And now I can see that 2 goes into both of those, right? That's 2 times that, and that's 2 times x. So if I bring a 2 to the front, like that. There we go. Let's pop some brackets around that so you know what I'm integrating. Now it looks really similar, doesn't it look? So we've got a plus there, we had a minus in part A, so I'm just going to do a bit of a sort of a little fiddle here. I want to basically use the result from part A, so I'm going to write the result from part A, which is 2 to the power of x squared minus x, and then I'm going to adjust this to make it look like that, so I have to add 2x. Now, the whole point of writing it in terms of the answer to part A was that we can separate that off. So we've got two lots of minus 0.5 to 1.5, 2x squared minus x. So that's our answer from part A. So double the answer from part A. Then you can see plus this 2x still needs to be integrated. So it's two lots of the integral of 2x dx. So this one, two lots of, what did we say it was, 2.58. So that was your answer to part A, that bit there. And then adding on two lots of, integrate 2x very easily. And what's that, 5.16 plus, and you can integrate that very easily. That turns out to be two lots of 2. So overall, final answer, 9.16.